Focus, focus. Alright, y'all, this is a 3D printed model of one of my paper engines. And it actually came out better than expected. Look at it. Came out much better than expected. Same design, flywheel, your crankshaft in there, one piston, the airways, the sliding valve in there, the air valve, exhaust, and your intake. Let me show you that sliding valve. Look, the same exact design. The same exact design I use on my other engines, but I never made a single cylinder with this type of sliding valve. I do like this sliding valve a lot because it's only one part. Usually it'll be a rod connected to the sliding valve that's connected to this, and that would be like 2 or 3 different parts. This is only one, so saving space, less complexity. And yeah, it's pretty cool. It is pretty cool. It can run off vacuum or compressed air, and I'm gonna demonstrate that using my lungs. So let me hook this thing up. There we go. Oh yeah, we got the engine stand on here now. Got the engine stand. I do have to redesign it because it's too close to the flywheel. I need to lift it up just a little bit more. Yeah, just a little bit more. Let me show you what I'm talking about. Look at the clearance. Look, right there. The flywheel is touching the engine stand. So, yeah, I had to redesign that. You can see the internals moving on the inside of the crankcase. I had to put a hole in there so the engine can breathe. And yeah, everything is running smooth. Let me give y'all a little test run real quick. Oh yeah, and my turbo blade that I made for this engine cracked on me. Oh snap, it's actually falling apart now. But it cracked, so I can't show y'all a good demonstration right now with the turbo on it. But still pretty cool. Let me show y'all what it runs like. I'm gonna inhale for this first run. Yeah, that thing is noisy, but it's because the flywheel. I see what's going on. Yeah, let me slide that over just a hair. Let's give it another run. Let me let y'all see that sliding valve in action. I think what happened? Did the flywheel hit this thing? Yeah, I definitely have to do something about that engine stand. But I never had an engine stand before, so it's pretty cool to have one though. And yeah, this thing is pretty cool. And that was me inhaling. I can exhale as well. Let me see what it runs like if I exhale. I'm gonna blow into it basically. Yeah, and this is more tolerable if you blow into it compared to a paper engine, because it doesn't really matter if moisture gets in here compared to paper, because the paper actually get wet and start to mess the engine up. But this is plastic, so I guess it can handle a little bit of moisture. But I'm not going to be blowing in this thing. I'm really going to be inhaling if I use it at all, or I'm going to hook it up to the air compressor. Oh yeah, I'm going to give y'all a run on that air compressor too. I'm going to give y'all a... Alright, we have this thing hooked up to the air compressor for the very first time, and I want to see how it runs. So let's see. Oh. That's fast. Oh man, the shaft snapped. No more flywheel. No. Well, not only did the flywheel come off, but I think the flywheel came off because the engine actually locked up. Like, look, you can see this is rotating without the timing shaft rotating. So something on the inside broke. I'm gonna open it up and I'm gonna see exactly what happened. Alright, so we got the piston right here. We can see the inside. As you can see, is that the shaft that... Oh yeah, I guess it was too much power coming from the piston, and it snapped that. And then while it was rotating, it locked up. The flywheel, the energy in the flywheel was stored, which caused the flywheel to keep spinning while the shaft locked up, which put pressure on this shaft, which caused it to snap. So what I would have to do, well, what I'm thinking about doing is just making that a little thicker, making that shaft thicker. Guys, this is crazy. Alright, so I broke the engine, opened the crankcase. The piston looks good. This thing, nothing happened to it. But yeah, this is the shaft that snapped first, and it was connected to that side right there. So that shaft snapped. This part still connected good to the timing shaft. As you can see, still 90 degrees ahead. So this shaft had no problem with the higher pressures. It was just this part, because this is the main power source right there. So it took a lot of pressure, and yeah, it snapped. So I'm gonna have to make this hole a little bigger for a larger shaft. And yeah, that's gonna be fun. This is fun. That was a good test for the very first time of me making a 3D printed engine. Pretty good test. Let me know what y'all think inside the comments. We came from making paper engines to 3D printing my engine. A lot of people been asking for this stuff, so I did it. And also I just learned it. I was gonna do it anyway. Hey, this thing comes out. Yeah, I was gonna do it anyway, but this is only the beginning. Stay tuned, we got a lot more coming. This is only the single cylinder. We still got the V-twin, the flat twin, the flat 4, the inline 4, the V4, and the V6, inline 6, V8s. We got everything coming. We got vehicles coming. This was my paper car with the V4 on it. We got a lot of stuff coming. We got a lot of stuff coming, y'all. So stay tuned. Check out my other channels if you want to make one of these out of paper. And yeah, let me know what y'all think inside the comment section.